All right. Let's discuss. Question 1. What do you think? Exponential. All right? Exponential. And why is it exponential? What would you use or what would you say to prove that it's exponential? It's doubling, which is a common ratio. Good. So you hear the word double in there, which is a common, or it's a constant ratio is what that is. Constant ratio. So if I had to prove it, if it said, what is it, and like justify your answer, the justification I would be is that it's got a constant ratio. I'm multiplying by 2 every time. Okay? All right. Number 2. Number 2 is a little tricky. That's what I told you at the beginning. All right? Any thoughts on this one? Linear. Okay? And why did you say linear?
Because it's going by 1 every time.
Okay, what's going by 1 every time? The radius is increasing by 1 every time. You have regular intervals. All right? So that's kind of a constant deal. So that's kind of I'm leaning towards linear when it says that. Okay? Now, here's the question though. Okay? So that's kind of linear there. All right? What's it asking me to find in this one? What's she trying to calculate? The area, correct? So, if I'm talking about area, what's the shape of a puddle? A circle. So what's the area for a circle? Pi r squared. Okay? And so, because it's saying about the area, this one is actually, what does that look like to you? Not exponential. That's quadratic. Okay? So is it quadratic? So, on this one, it kind of depends on what it's asking. And specifically what it was asking on this one is it's asking about the area. Since it's asking about the area, quadratic is the best answer. Okay? If it asked me about the radius, then the radius would be linear. Does that make sense? Okay? The radius is linear. The area is quadratic. Now, if you think about it, what was our definition for quadratic? A linear rate of change. All right? So what's the radius doing? It's changing linear. All right? So that's kind of what's going on. That was kind of tricky. You got to make sure that you're focusing on what they're asking. Number 3. Number 3 is pretty straightforward. What's number 3? Linear. What is this? You're gun shy now. That is, yeah. So this is my constant rate of change. That's my constant rate of change. What's this? That's my y-intercept. So technically, I could go and write the equation for this. 0.35x plus 2.50. There would be my cost function. So that is linear. Okay? All right? And the last one. Quadratic. Okay? Everybody agree it's a quadratic?
Yes. Yeah. I believe it's nothing.
You believe it's nothing?
Yeah.
Why?
Because there's no constant.
Because you want one of everyone is what you want. Now there's 4 and there's 4 categories, so you want one of everything.
Life isn't all sunshine and rainbows. It's none.
It's none. Okay? Why did you say it's quadratic? It goes up and then it goes back down, right? Which, of all the models that we have, linear doesn't do that, exponential doesn't do that, but quadratic does. It goes up and it goes back down. Now, here's the one thing that I need you to look at on this one. All right? On a quick glance, I would agree with you. It is quadratic. Okay? But look here. This is 6 at 6 a.m. It's 54 degrees. At 9 a.m. it is 60 degrees. At 12 it is 67. Go ahead. There you go. All right. I'll just pause. All right. At 3 p.m. you could say that's 1,500 hours. That would be Army time. All right. This is 6. And let's see. That would be 60. And that would be 54. Okay. So there's the data. If I wrote it down. Now, what is your change here? It went up 6. Change there. It definitely did not write this problem in the, right here. What's this one?
7.
Yeah. Here's what I need you to see. All right. This is where it's not quadratic.
It's not quadratic.
If I did this, if I drew the parabola, because it goes up and it goes down, how steep is this slope right here? Pretty steep. How steep is this one? Not as steep. And then right here, it gets less and less, right? What's this one doing?
It's going up.
Pretty steep, but then it's getting steeper. That makes sense? So it's like it's going here, then it's getting steeper, then it's going down, and it's getting less steep. That's a picture of what's going on there. So does it kind of model quadratic a little bit? Yeah, but it's really not either of them. Okay? So this is the one that was done.
Boom!
Okay? Now, you are on page 6, not page 6, page 2, excuse me. You're on page 2. Here's what I want you to do the remainder of the time, all right? I want you to pick a scenario, either linear, quadratic, or exponential, and I want you to write me a little scenario about it, okay? You're writing a scenario that we have up here, but you may pick linear, you may pick quadratic, you may pick exponential. You're writing it on page 2, all right? And that's the remainder of the class today, all right? So write a little situation that would match one of those functions, linear, quadratic, exponential.
Oh, it
Right.
can't be the 9.
I mean, if you want to write a 9, you can.
You cannot Google it.